This is your Math Gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. Alright, this is the second video where we're going to compare what happens if you put a certain amount of money in an account for a certain number of years. And in this problem, in all of these problems, we're talking about investing $15,000 at 8% for 10 years. But first we're going to see how much money we would have in the account if we are only earning simple interest. Next we'll see what happens if we are having our interest compounded yearly. And thirdly, we'll see how much we have at the account in the account after 10 years if our interest is compounded monthly, in other words 12 times a year. I am not going to show you the individual keystrokes on a calculator this time, but you can look back at the previous video. Just make sure you know the order of operations and whether your own calculator does it or not. You have to be very careful the way you enter the numbers. So here's the first problem. 15,000 at 8% simple interest for 10 years. So we know that P is the principal. How much money we put in the account. Our rate, that will be the percentage rate. 8%, how about we write that as 800ths? And the time, how many years? 10 years. Now keep in mind, you could put 0.08 for the rate as well. So the interest I earn in this count will be 15,000 times the rate, 800ths, times 10 years. Now, you could do all this in your calculator. I tend to not do it in the calculator because I'm faster doing it this way. So if you put 0.08 and you plug all this in, you're going to get the same answer I do. So I cancel out those zeros, so I have 150 times 8 times 10, and I'm going to do 15 times 8. Well, 15 times 2 is 30. Then I can multiply that by 4, so it's going to be 120. So 15 times 8 is 120. Then I have this extra 0 from the 150 and the extra 0 for the 10. So the amount of interest earned is $12,000. Hopefully if you put in 15,000 times 0.08 times 10, you got the same answer. Now the question asks how much money is in the account after 10 years. So this is just the interest, right? So we of course would have to add the money we put in at the beginning, and that gives us our grand total in our account of $27,000. So that's how much is in the account after 10 years if we put in $15,000 simple interest account. All right, now let's do this next problem. We're going to compound it yearly. So here is our formula. A equals P times 1 plus R over N to the NT. And we have to remember what each of these letters stands for. P is the principal. That means how much money we're putting in the account. We're putting in $15,000. R is our interest rate. So that'll be 0.08. N is how many times per year it's compounded. Well, if it's yearly, N is just 1. And T is our time. In this case, we're doing it for 10 years. All right, so what I want you to do is put these in the formula and see if you can come up with the answer yourself, plugging everything in the calculator correctly, maybe double checking, and seeing what you get for the total amount of money that you would have in the account after 10 years. Okay, so first of all, how you would write the problem. You would write P, which is 15,000, times 1 plus 0.08 over 1, right, will just be 0.08. And then I've got to do 10 times 1, right, N times T, that'll just be 10. So we end up with 15,000 times 1.08 to the 10th power. And when I enter it in my calculator, I get $32,383.87 after I've rounded to the nearest cent. The way I keystroked it is I put 1.08, then I used the symbol for raising something to a power, which could be y to the x, or it might be a little caret thing that looks like this. Okay. And then I put in 10 to say what the exponent is. I wrote equal, so I get some number, and then I multiplied it by 15,000. And this is the amount I got. All right, now let's compare that for a minute. What was this next compared to when I did simple interest? So just keep in mind this is about 32,000. Notice we had 27,000 doing it the other way. So quite a bit of difference, $5,000. All right, let's now compound it monthly. So I want you to try this all on your own. Write down what your variables are for P, R, N, and T. Plug it in the formula and figure out how to enter all that in your calculator and compute. Okay, so let's go for it. We've got the principal is 15,000. We've got the rate is 0.08. Okay, and how many times per year? Well, monthly means 12 months a year, and it'll be 12. And how many years? We've got 10 years. So if we plug this in, we've got 15,000 times 1 plus 0.08 divided by 12. 2, the n times t, that's 12 times 10, right? Which is going to be 120. So I'm going to simplify this just a little bit before I use my calculator. Think of that 1 as 12 over 12, so I could add my numerators, and I'm going to have 12.08 divided by 12. And 12 times 10 is 120. And now I'm going to enter that in my calculator. So to do 12.8 divided by 12, you do that first. When you enter it in your calculator, first write 12.08 divided by 12 equals. So you get that number, and then you use the y to the x or the caret to raise it to the 120th power, equals, and then times your answer by 15,000. All right, when I entered it in my calculator, I got $33,294.60. I haven't double checked it, but I should probably do that. I always suggest you do your calculation more than once. So let's see, this is about $33,000 when we did it monthly instead of yearly. How much was it when we did it yearly? $32,000. Okay, so you made a little bit more money, but it's not as great of a difference as when you do it with simple interest. Okay. Also, if this changes to 20 years, and I think that's what I did in my video on the last example, it's a huge difference. You know, the more years you're compounding interest, and then you're getting paid on that new interest all the time. It just is greater and greater the more years that go on. So compound interest makes a huge difference. Okay, so let's look at the three side by side. So we have the final results. The amount in an account after investing $15,000 at 8% for a certain number of years using simple interest, if it's compounded yearly or it's compounded monthly. This is your Math Gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.